Hello, my name is Kateryna Akhynko, and today I will be presenting our work named Hidden Persuasion, Detecting Manipulative Narratives on Social Media During the 2022 Russian Invasion of Ukraine. My co-authors are Oleksandr Kosovan and Mykola Trokhymovych. I would like to start by outlining the importance of this topic. Telegram has become one of the most influential platforms in Ukraine. According to a 2024 USAID Internews survey, 73% of Ukrainians now use Telegram as their primary source of information. Moreover, 81% of Ukrainians use Telegram as a social network too, which increases its importance in everyday life. This raises a question. If we use Telegram so much, can we trust its transparency and reliability? Let's take a closer look at some of the examples. On the slide, you can see the example of news post from famous Telegram channel. It might seem like there is nothing wrong with it, but if we analyze it better, we see that there are certain features that may influence reader. For example, there is an emoji at the beginning and at the very end. There is some text highlighted in bold. There are some side comments by an unknown author. And also, it is important that this post was seen by more than 800,000 people. Now let's look at another Telegram post, and again, it might seem that it is innocent, but still there is some text highlighted in bold, there are some side comments again, and this post was viewed by even more people, 1 million people. And in this context, we would like to define the specific problem that will be solved in our work. And our goal is to detect manipulative narratives in Ukrainian Telegram posts. It is also important to define what exactly is a manipulation in this work. We used the definition of UNLP 2025 shared task, and it is specifically the use of rhetorical or stylistic techniques to influence readers' opinions or behavior without relying on factual evidence. These techniques might include exaggeration, appeals to emotion, or other forms of persuasive language. We will also aim to solve two subtasks. The first one is technique classification, so we want to get the specific list of manipulation techniques that were used in a given text. This is treated as a multi-label classification task, since a single message can contain more than one type of manipulation. And also we want to define the exact part of the text where manipulation occurs. This is a binary classification task, meaning that each character is labeled as either manipulative or not. The idea is to highlight specific spans of text that contribute to the overall manipulative effect. And it is important that it is regardless of which technique is being used in that span. We started our work by data overview. The main data source for this work was provided by UNLP 2025 shared task. The dataset consists of Telegram posts from Ukrainian channels, and each post was annotated with manipulation techniques and manipulative spans. There are also two languages present, Ukrainian and Russian, and we can see that there is an imbalance between the languages and between the distribution of manipulative and non-manipulative texts in each language. And also we were given 10 predefined manipulative techniques. And again, there is a huge imbalance between the classes and also how the posts in different languages are distributed between each class. Now let's move to the solution that we propose for each subtask. And the first solution is for the technique classification subtask. And here we suggest a three-stage pipeline. The first two stages involved a fine-tuning of an LLM. We chose Gemma to be IT model as at the base for this architecture, and it And two different types of fine-tuning were applied. At first, that was causal language modeling, and then we moved to multi-label sequence classification training. For that, we also used LoRa adapter to optimize the process and make it faster, especially um, in with constrained resources. And after it was fine-tuned, we got the class probabilities that were the output of this two-stage fine-tuning, and we post-processed the results using the cat boost and got the final predictions. For the solution of span identification subtask. For this task, we wanted to explore the capabilities of two-headed transformer architecture. And our main goal was to explore how it will behave when we will try to solve two subtasks at the same time. So by adding two classification heads on top of one shared encoder, um, we wanted to see whether these two subtasks could be solved and get good results. By adding these two heads and combining losses and optimizing loss and modifying the weights for each loss, we were getting different results. To compare these results, we used the metrics again that were provided by UNLP shared task. These are macro averaged F1 score and span level F1 score. And the results for technique classifications of task are the following. You can see the leaderboard, the results from the leaderboard of top three teams. We can see that the comparison between the between the results from the first two stages of our architecture and comparison of that to the full pipeline with three stages is really important because even though we could still guarantee as a second place for ourselves, even with a two-stage pipeline, we won by a large margin by applying this post-processing. And that is why we could be sure that we would have this second place. And it is also important to see the results class-wise because even though we would expect that the classes that are well represented in the dataset, like loaded language and glutarian generalities, they would get a high F1 score. That is not the case for such classes as cherry picking, for example, which is also well represented, even better than glutarian generalities, but still it got much worse result, much worse F1 score. And for the span identification, here we see that we can compare this two-headed architecture to just one-headed architecture, just a simple encoder and classification head on top, just to solve this span identification subtask. And we see that by leveraging this advanced architecture, we were able to get the third place on the leaderboard. And for the conclusions, we have achieved second place in technique classification subtask and third place in span detection in the UNLP 2025 shared task. Also, we explored the capabilities of Gemma 2 model, especially with two-stage fine-tuning and also post-processing of its results with meta features, and how significantly we could boost the performance with exactly this architecture. And also it is important that we showed that a simple model like XLM Roberta can achieve top-tier results when used in a specifically crafted pipeline which was a two-headed transformer model in our case. Thank you for your attention.